Hello guys, hope you're doing well. Last class we have been talking about sequences and series. In this class we will continue about these sequences and series, but before continuing let's start to do some review. So as we said, in each sequence, which is a series of numbers, for each one of these numbers we have the index of these numbers. For example, this one is the first one, while this one is the nth term. So we have the numbers and we have the indices of these numbers. So for each one of these sequences we can define the formula of an. In this case an equals 2 multiplied by the index of this number. So for each sequence we can define the sequence by its own formula. In this case an equals 2n minus 1, while in this case it could be more complicated formula. It depends on the sequence. And we noticed that in this series Rn, or the nth term, depends only on the n, not the previous term. So in this case we have only n in this formula. And we said that we have also some special sequences, special defined sequences, which is the recursively defined sequences or the recursive sequences. In these sequences, instead of defining an only by n, we define the n or the nth term by the previous or the preceding terms. So for example, in this case we have an equals to 3 multiplied by the previous one, which is an minus 1. We could also define the nth term by more than one preceding terms. So to find each one of these terms we have to find the previous or the preceding terms. In this case it's giving that a1 is 1, so that's why we could find a2, a3 and a4 and a5 and so on until we get the number of terms we need in the questions. Let's take a very simple example about these types of recursively defined sequences. Let's say we have fn, which is a sequence defined by fn minus 1 plus fn minus 2. So basically in this sequence what I did is I took the nth term equals to the previous one, which is n minus 1, plus the preceding one, which is n minus 2. So basically what I'm doing is I'm just adding the last two terms to get the current term. So n equals the previous one, which is n minus 1 plus n minus 2. By the way, this is a very famous example. We call this Fibonacci sequence. So in this question he's asking me to find the first 11 terms in the sequence defined recursively by f1 equals 1 and f2 equals 1. So why did he give me these two first numbers? Because I cannot find the next one unless I have these two, because n defined by the last preceding terms. Okay, let's try to find these numbers or these terms. So to find f3, because we already have 1 and 2, to find f3 we just take f1 and f2 and we add them, we get f3. For f4 we take f3 plus f2 and we get f4. f5 the same way, we take the last two terms, we add them, we get the current one. So we can easily write the numbers of this sequence. So 1 because f1 and f2 is 1, f3 is 2, 3, 5, 8 and so on. So we call this a recursive sequence because each one of these terms depends on the previous or the preceding terms, and this is the basic and very simple example. We call this Fibonacci sequence. So guys, by the way, this series Fibonacci series or these numbers or these terms, we can find it in so many applications, and one of the funny application is the golden ratio. I guess you've seen this figure before on the internet. So look at these numbers: 1, 1, which is F1, F2, F3, and F4, and F5, and so on. These are the terms of this sequence. So each one of these numbers is the addition of the previous two. So this 2 equals 1 plus 1, this 3 is 2 plus 1, this 8 is 5 plus 3. So basically Fibonacci sequence we can lead us to the golden ratio, as we can see in this figure. You can check this online, guys. It's some of the application of this series. Okay, so guys, after speaking about the sequences, let's take a new definition. For the sequence A1, A2, and A4, and AN, we can define the partial sums. These sums defined by S1, for example, in this case, equals the first one, while S2 equals A1 plus A2, S3 equals A1, A2 plus A3. So basically what I'm doing is, for Sn, I'm adding all the numbers from A1 until we get to this n. So we call these sums partial sums, and this one is the nth partial sum. So basically for S4, I'm adding all the terms from A1, or the first term, until we get the nth, or the fourth, in this case, term. We call these partial sums. The first partial sum, the second partial sum, the nth partial sums. Let's take an example about this. So guys, in this question is asking me, find the first 4 partial sums and the nth partial sum of this sequence given by an equals 1 over 2n. So maybe we will get this question: where are these terms? Where are the numbers? I cannot see the numbers. I have only this an equals 1 over 2n. So basically you can find the number by just plugging, instead of n, the numbers. So to find a1 of this series, a1 equals 1 over 2 to power 1, which is in this case 1 over 2, while the second term is 1 over 2 to the power 2, which is 1 over 4. This 1 over 8 comes from an equals to 1 over 2 to power 3, because the index of this term is 3, and so on. So this is the first step, is to find the numbers, the terms of this sequence, by just plugging in this formula. To find the sums or the partial sums, we can immediately start by S1, which is immediately the first one. S2, we take these two, we add them, we will get the number. S3, we A1, A2, A3, and we will get the answer. S4, because he's asking me the first 4 partial sums, 1 and A2, A3, and A4 equals S4. So basically guys, the question is trying to find a general formula for the Sn. So he's trying to find a formula immediately. Instead of having the number or the index as a number, we need the index to be an n. So in this case, we can notice that each one of these denominators is a power of 2, and this numerator is the same as denominator minus 1. So he said Sn could be 2 power n minus 1 over 2, and this is the general formula to find the partial sum nth term. But guys, normally when we have a question of like this, normally we are given the Sn or the formula of this partial sum. So basically we have 2 formulas. The first one is the nth term, which is in this case an 1 over 2 over 2 to power n. From this one I can find all the numbers, all the terms of the sequence. The second formula, which is the partial sum, which is in this case Sn, this allows me to find all the partial sums of this sequence. And normally this is given and this one also is given. So what I have to do is I just have to find the numbers and I have to plug, instead of n, I have to plug the index of n to find the partial sums. For example, guys, look at this question. In this question, find the first four partial sums of the nth partial sum of the sequence given by this. So I have the formula of the sequence, which is an. So I can find the S1 by just finding the terms of each one of these and add them. So S1 equals A1, S2 it's A1 plus A2, S3 equals A1 plus A2 plus A3, S4 and so on. And we have the answer in this case. So he's asking me whether I can notice that I have a pattern here to find the general formula for the nth partial sums, in this case, which is 1 minus 1 over n plus 1. As I told you guys, normally we are giving this formula and this formula. Thank you so much. See you.